One of the rules of our natural deduction system is the disjunction elimination rule. It's a rule that allows you to argue from a disjunction. Disjunctions can be tricky to argue from because a disjunction doesn't make a particularly strong claim. A disjunction holds back. It's somewhat non-committal in the sense that the disjunction alpha or beta doesn't say definitively that alpha is true, nor does it say definitively that beta is true. It just says that at least one of those two claims is true without taking a stand on which. Because disjunctions are non-committal in that way, we have to combine them with further information if we want to reach any definitive conclusion from them. So our rule for arguing from a disjunction says that if you have a disjunction alpha or beta, and you've shown that both alpha and beta lead to a certain conclusion gamma, in other words, you've laid out a subproof from alpha to gamma and also a subproof from beta to gamma, then you can derive the conclusion gamma. It's absolutely critical to show that both disjuncts lead to a conclusion before you derive that conclusion. Showing that one of the disjuncts leads there wouldn't be enough. And that goes back to the fact that a disjunction just tells you that at least one of the disjuncts is true without taking a stand on which. So if all you can show is that the first disjunct alpha leads to the conclusion gamma, then you're stuck. You can't say that gamma must be true because the disjunction doesn't tell you that alpha is true. Likewise, if all you can show is that the second disjunct beta leads to the conclusion gamma, then once again, you're stuck because the disjunction doesn't tell you that beta is true. All it tells you is that at least one of alpha and beta is true. So you have to be able to show that both alpha and beta lead to the conclusion gamma before you can derive gamma. Now, I've been saying that disjunctions are in a sense non-committal because the disjunction alpha or beta doesn't say definitively that alpha is true, nor does it say definitively that beta is true. However, it's important to realize that a disjunction is not entirely silent. It does take a kind of stand. It's still informative to be told that at least one of alpha and beta must be true, even if you're not told which. So the disjunction alpha or beta does tell us something important, even if it doesn't narrow the options down all the way. It does narrow them down to alpha and beta. It tells us that at least one of those claims must be true. So if we can show that both of those claims lead to a conclusion gamma, then we can indeed be assured that gamma holds. That's the idea behind the disjunction elimination rule. Now let's look at one example where you have to use the disjunction elimination rule to complete a proof. So let's suppose that from the premises not P or not Q and not Q and P, we have to derive not P. And let's think about what the overall outline of the proof might be and then try to fill in the details. Because the first premise is a disjunction, our overall strategy could be to show that both disjuncts lead to our conclusion, not P. That's a particularly tempting strategy to try in this case because the first disjunct is itself the conclusion that we're ultimately trying to derive. So we know straight away that we're not going to have any problem deriving not P from the first disjunct. That just takes one application of the iteration rule. All we have left to do, if we follow this strategy, is to show that the second disjunct, not Q, also leads to the conclusion, not P. So let's see if we can show that. How might we derive not P under the supposition that not Q is true? An obvious strategy is to further temporarily suppose that P is true and then derive absurdity under that supposition, which would allow us to derive not P under the supposition not Q. Now, the second premise is the negation of the conjunction of not Q and P, and that very conjunction can very easily be derived once we've further supposed that P is true from lines 5 and 6. So we can derive absurdity under the supposition P by appeal to lines 7 and 2. That gets us not P back under the supposition not Q. So now we've shown that both disjuncts of line 1 lead to the conclusion not P. Hence, we're entitled to conclude from line 1 together with the subproof from 3 to 4 and the subproof from 5 to 9 that not P holds. Let me close by mentioning one other way it might have occurred to you to complete this same proof. Since we're talking about the disjunction elimination rule right now, the proof strategy that I just covered, where we showed that both not P and not Q lead to the conclusion not P, might have been the first one to occur to you. But if this problem wasn't part of a lesson about the disjunction elimination rule, another strategy you might have tried in order to derive not P is temporarily supposing P and then deriving absurdity, since that's a strategy we often employ when we want to derive the negation of something and our conclusion is the negation of P. And that strategy would also work. Even if you went with this strategy, you would end up using the disjunction elimination rule somewhere along the way, but you don't have to structure the proof in exactly the way we did just a moment ago. So, for example, one way to fill in the details if you go this second route, where we assume P and then aim for absurdity, is to try to show under the supposition P that both disjuncts of the first premise lead to absurdity. That would allow us to derive absurdity under the supposition P using the disjunction elimination rule. Supposing not P leads to absurdity right away, it can be derived immediately from lines 3 and 4. Supposing not Q also leads to absurdity because we can derive the conjunction not Q and P from lines 6 and 3, which is the very conjunction that's being negated by the second premise. So temporarily supposing P ultimately leads to absurdity, and hence we can conclude not P. Another way to fill in the details would be to try to derive absurdity under the supposition P by deriving the conjunction not Q and P in that subproof, because that conjunction could then be combined with the second premise to derive absurdity. To get not Q and P, we would just need to derive not Q, because that would give us both not Q and P separately. And we could try to get not Q by assuming Q and then deriving absurdity. How could we get absurdity under the supposition Q? We could make use of the disjunctive first premise. Both disjuncts would immediately lead to absurdity given our suppositions up to this point. We can derive absurdity under not P from lines 3 and 5, and we can derive absurdity under not Q from lines 4 and 7. Appealing to the first premise and those two subproofs, we can derive absurdity under the supposition Q. That gets us not Q, which gets us the conjunction not Q and P, which gets us absurdity under the supposition P, so we can ultimately conclude not P. Of the three proofs we wrote out, the first is perhaps the most elegant, but all of them are correct derivations of the conclusion from the premises.